Welcome to the video for 7.4. So as you knew from what we did in class, this video is all going to be about right triangles and similarity. So we're going to use the right triangle altitude similarity theorem. We're going to learn what a geometric mean is and how that can help me solve these things much faster. And then we're going to learn about the right triangle altitude and the right triangle altitude leg theorem. So let's jump into it. So the right triangle altitude similarity theorem is where, and this is what we did in class, if I have this drawn altitude, then I get three triangles that are similar. So I'm going to show this. So here I have a right triangle, altitude's right here. This angle here and this angle here will add up to 90 because this is a 90-degree angle. If I keep going, that angle goes there, that angle goes there, which we knew, but now this angle equals this angle equals that angle. So we have two triangles that are small that have a blue and a red, blue and red, and then one triangle that's big that has a blue and a red. So all three of these triangles are congruent, and that's going to really help us out with learning all these other theorems. So the geometric mean is a term, and we're going to use it when we have altitudes and right triangles. But essentially, if I have a number and it's over x equals the same number x over b. So if I were to solve this, I would cross multiply, get x squared equals, let me change the number, which should be variable like a. Maybe we should write a there. A times b. Okay, and then I'd square root that. So you might also see, if you look this up, that the geometric mean is x equals the square root of a times b. So once I know this, if I figure out what geometric mean is, I can then just take the two numbers, multiply them together, take the square root, and I get the answer for x. So the first one is the right triangle altitude hypotenuse theorem. So as with all these for 7.4, I have a right triangle and I have an altitude drawn. So what this one states is the right triangle to its hypotenuse is the geometric mean between the measures of the two segments of the hypotenuse. So this piece is in common with two different triangles. This piece relates to this piece if it were little triangle, long leg, big triangle, long leg. This piece here relates to this side, short leg, short leg. So let me just go to this. So the blue side here, this one, is used in both. So if I make up a proportion, short leg over long leg, I get orange over blue. And then I do the same proportion of the other triangle, short leg over long leg, I'm using blue twice. So this is my geometric mean. So I can take this length of the half of a hypotenuse of the big triangle and this one, and I can then multiply those together and take the square root, and it will be the same thing as 4.5. So let's go and try one. Okay, so this triangle, this would be x, is my geometric mean. So it's going to be 4 over x equals x over 9. I could also say x over 4 equals 9 over x. Either way, I cross multiply, I get x squared equals 36. Take the square root, x is 6. Here's another one. I'm going to make the proportion. This length is my geometric mean. So 8 over 4 equals x over 8. Going to cross multiply. I won't even have to cross multiply. I am just going to multiply each side by 8. 8 and the 4 cancel, so it's a 2 and a 1. So this length is 16. So all I need to know is if I have this length and I have the two lengths on either side. Oh, what a marker there. If I have these three lengths, I use the altitude as the geometric mean. Another theorem is the right triangle altitude leg theorem. Before it was the hypotenuse theorem. So what's going to be different is I'm going to be using legs. So if the altitude is drawn to the hypotenuse of a right triangle, each leg of the right triangle is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Well, let's look at what this means with our picture. So I'm going to click on point A. So point A, if I look down here, this small triangle, orange and red. So if I do short leg over hypotenuse, it would be orange over red. And then I look over here, I have red again and black. And if I do short leg over hypotenuse, I have the red used twice. So this is the geometric mean. So if I have this length, I will use it twice. I'll use this length once and the whole length once. The same thing goes if I'm on this side of the triangle. 8.1, that's my green side. This is green. This is green. It's the same length. It's going to be used twice. It's the geometric mean. So the side I used once is just this side and then the whole side. So let's go back and we are going to try a couple of these problems. Okay, so I'm looking, I don't have the altitude, so I wouldn't use the previous theorem. I'd use the new one. And that's going to be, this side is used twice. So it's going to be, oh, I need a marker. X over equals a number over X. So it's going to be X over 20. And then it's not 4. It's going to be the whole thing. The whole thing's 24. So sometimes you have to add those up. You'll get 24 there. So this one, cross multiply, I get X squared equals 20 times 24, 480. Take the square root of 480. And I get X equals 21.9. If I wanted to do the shortcut, more geometric mean, X would be equal to the square root of 20 times 24. I talked about that at the beginning. That would still be the square root of 480. So set the equation up if you want, or just be able to look at this and say, oh, this side would be used twice in my similarity statement. So it would be on the top and bottom. And then this side is used once and the whole side is used once. So why don't you pause the video and you do this one. Okay, welcome back. So hopefully you guys saw that this side is going to be my geometric mean. So it's X over equals something over X. This side would be there. And then the whole side is 8. So I can say, well, cross multiply X squared equals 16, square root X equals 4. Or I could just say square root of 2 times 8, which is the square root of 16, which is still 4. So this is geometric mean in a nutshell. You got to look at the picture and identify, do I have the altitude? If I have the altitude, then I'll use this side and this side. If I have the short leg here of the big triangle, then I will use the short leg twice and the little piece and the whole piece. And if I have the long leg, or either leg actually, I would use the same setup, the leg as the geometric mean, and then the short piece, and then the whole piece of the big triangle. So hopefully this makes some sense. If not, ask me questions, and the you do it is on page 506. I want you to do 4A.